Okay. So we have finished with surface tension recently. Okay. So we just completed our fluid mechanics part. Just give me 10 seconds. Okay. So sorry for the disturbance. So we have just completed our surface tension chapter. Now we are moving on to the thermal properties of matter. And the very first chapter that we are dealing with, thermodynamics and KTG. KTG is nothing here is kinetic theory of gases. So we will deal firstly with thermodynamics, which is easier to crack. Then we will move to KTG, which is much more easier than thermodynamics. So, and then after we will study the thermal properties of matter and calorimetry. So this is going to be our strategy to cover these thermal chapter, thermal physics. So firstly, and obviously this is not lecture number 4. This is lecture number 1. Just give me a second. I will just correct it. This is lecture 1. So yeah. So how are you guys? Full on energy? Okay. So we'll just start it. Now, what do you know about thermodynamics? Have you ever heard about it? Any kind of discussion that you want to do with me about thermodynamics? Like, sir, we have covered this. Have you covered this chapter in your JNV? Are good evening. Good evening to everyone. How are you? So I'm asking you that thermodynamics is covered in your JNV, in your regular classes. And this is also a regular classes. Okay. So some of the students saying yes, sir. Some of the students saying no, sir. I will consider both of them, and we'll start with a very fresh of it. Okay. So thermodynamics mein, what is our learning objective? Firstly, we will see the basic terminology and basic of thermodynamics. We will first deal to crack the advanced part of it. Then we will deal with the laws of thermodynamics. After that, heat engine. And this is it. So these 3 topics we have to cover, not today. This is the complete syllabus of thermodynamics. That today we are going to deal about only the thermodynamics and the basics of zeroth law of thermodynamics, concept of temperature. Okay. So thermodynamics, if you will see, it is made up of 2 words, thermo and dynamics. Okay. Thermo means heat. Okay. And dynamics, we have already covered the part of mechanics. Dynamics part deals with when we consider the cause of the motion. Okay. So when the thermodynamics says us कि whenever we have heat, okay, and we are applying force in terms of heat. Now you can imagine how we can apply force with the help of heat. Yes, you can. If you have a pot of water and you are just start boiling it, so when water boils, what happens? The lid that you have covered the pot, it will start open up. Yeah. As the water heat up, it will form the vapor, and these vapors apply the force on that lid and it will open. Okay. Whenever we hot warm the milk that we get, okay, जब भी हम दूध को boil करते हैं, so it generally happen with us कि when the milk boils up, so it will remove that lid that is placed on the top of that pot. So it is somehow by this given heat, we have facing a force there. So the deal is here that when we consider the effect of heat in terms of force, okay, or let me explain it very finely. Just a second. Okay. So this is heat and this is force involved in conversion dynamics. So the thermodynamics is the branch of physics that deal with the concept of heat and temperature and the interconversion of heat with the other forms of energy. You must have heard about the concept of steam engine. So whatever is happening, what is happening in that? We boil the water. When we boil the water, the steam will be formed there. That steam will hit the blades of the turbine, and the turbine rotate, and the engine will start working. So basic thing here is that we are converting the heat energy into some another useful form of energy, which is work. Okay, work is nothing but the useful form of energy. And in the case of steam engine, it is mechanical energy. So thermodynamics deal with that part of the thermal physics. Then when we are interested in the concept of heat, temperature, and interconversion of this heat energy with another forms of energy. Now, one thing here you should note that when we are dealing with thermodynamics, we are only interested in the conversion part, not in the we are not interested in how much amount of heat is causing that much amount of conversion in that particular time frame. Okay, we are not interested in time, how long the process would take to develop these heats or convert these heat, how long this process is going on. We are not interested in that in thermodynamics especially. So there is another branch of physics which is heat and mass transfer. So we are interested in the heat rate there, transfer rate. Okay, so we are only restricted to this only, so we are going to study this. So I think you are clear with the definition of thermodynamics. Thermo means heat, dynamics means the force, or the force that we need in conversion, or that we get in the conversion of heat into some another forms of energy. So whenever we convert the heat into some another form of energy, we get a work or we get a force applied. So that is combinedly seen as thermodynamics. Okay. Now, work and heat are the interconvertible. Yeah, obviously, because if you do the work, the heat will be generated. If you heat up something, the work will be done. Now, I can explain it to you right here. Whenever you rub your hand, whenever we rub your hand, and nowadays in the in the weather of winter, we usually do that to warm our hand. So what we are doing? We are rubbing our hand with each other. We are doing work, and this get warmer. Why? Because work here, with that the work that we are doing in rubbing this is converted into the heat. So we can say that heat is and work are interconvertible with each other. Now, the basic example is the rubbing of palms together. Why this is happening? Because work done by our palm get converted into the heat. Okay. Now, steam engine. Heat of steam engine is converted into mechanical energy. I have told you already. This is also a conversion. So you can see here, this is the kind of steam engine. Here we boil the water, and this is the piston which is compressing this. You don't need to understand that. Only the fact here is that heat here is converted into the mechanical work. That only you have to remember. Now, basic terminologies and zeroth law of thermodynamics. There is a story behind the zeroth law of thermodynamics. I will tell you. Now, basic terminologies, temperature and zeroth law of thermodynamics. That is we are going to study. So basic terminology में सबसे पहले we will study about the system. Now, what is a system? Okay. Suppose you have a boil a cup of water, okay, and someone came to you and told you and said you, ordered you. Now, to measure the temperature of that particular liquid that you have boiled in the cup of water, note in the water that is present allwhere of you. Okay? In your kitchen, there is water anywhere. You can see in the tap, in the another pot. But he ordered you, or you specifically want to study the temperature of that cup that you have boiled. So when you restrict yourself, your study to some particular conditions, that is not that is not but system. So the field of study in which we are interested in is called the system. This is a basic, very simple definition of system. So what is a system? The field of study. Okay, let's say any process, so that should be the system. If it is a mug, that should be the system. So system could be anything. Okay, and we also study the types of system. We will also study the types of system, but you have to understand the basic of it. So what the system is? System is nothing but the field of study. And whatever we are studying, what we are studying, we are interested in the temperature of that particular system. We are interested in the pressure of that particular system, the energy, the heat of the system. So these are the properties, or these are the characteristic of the system that we are interested to know. Like, okay, so that is system, the field of study. Let's say what the definition says. So a region in space in which our entire study is focused. This is simple. The study of focus, the focus of our study, the same part. So that is system. Suppose this is, let's say, the system. So we are only restricted to this part, which is inside of it. Okay. So that is our field of study, which is termed as system. So to understand the thermodynamics, you firstly understand the system in which you are interested. Okay. Suppose you blow a candle, you light up a candle, sorry. So if you restrict yourself, this is, let's say, the candle. Okay. This is not looking exactly like the candle, but you can imagine it. So if you are interested in only the candle, this should be the system of yours. Okay. But if you are not interested, if you take this as a system, not the candle, so this will be the circle. Okay. Suppose, for example, you have a bulb and you put that bulb in a container. So if the field of study, if you consider the system is bulb, so you will only interested in the temperature of that bulb. But if you consider this whole container as a system, then you have to consider the bulb itself and this part also. So when you change your system, the properties of the system and all the variables that is associated to the system will change. Okay. But you must remember the fact that what is a system? The system is the field of study. Okay. Now, moving next, the system can be changed based on our priority. So if we are interested in the bulb itself, so our system is bulb. And if we are interested in the whole container or the whole room in which that bulb is placed, so that whole room is our system. It is depends on our priority, that which object we want our system. Now, this you can see, this is the 4-cylinder 4-stroke engine. Okay. So do not worry if you are not understanding what this is. This is the basically 4-stroke engine which comes in our vehicle, automobile. So 4-wheeler में generally पाया जाता है. Okay. So this is the flywheel which is associated to the this deliver the power to the clutch plate, and clutch plate deliver the power to the wheels. Okay, so this is not our focus. Our focus is here is that you can consider it whole to be a system, but we are only interested that how much the heat is come, how much the pressure that heat has applied to the piston. So our study area is only this part which is dotted. Okay, so we are only interested in this volume which is inside this pistons. So this is our system here. Okay. Now what is surrounding? The one which is not system is surrounding. Everything other than the system is known as surrounding. Okay. And if you combine them, if this is the system of you have taken, so rest of it will become surrounding. Rest other thing will be considered in the surrounding. Okay. So what is boundary? So boundary is a very thin layer which separate system from the surrounding. Okay, it can be imaginary or it can be real. So we will see now features of boundary. It can be fixed or movable. या तो fix होगी या move करेगी. How it can be fixed? So whenever you are interested in this port, so inside of this port you will consider the system. So this outer layer of this port will become boundary of the system because it is separating the internal thing or the material that is present inside this port from the rest other thing. So this will be considered as a system, sorry, boundary. Okay, it is fixed because whenever you put the pot, you fill it with hot water or cold water or whatever it is. So you do not move this. Okay, if it is movable like this balloon, so this is the boundary. Okay, but here it is movable. If nitrogen or helium gas are filled in this. So it can be real or imaginary. And this real part is this. And suppose in case of candle, I have just assumed that this is our system. This is the candle we have seen. So this boundary does not exist really. We have imagined it. Okay. So that is the example for imaginary boundaries, which is not actually there, but we will consider for the separation of system and surrounding. Now, so negligible thickness we will consider for boundary because why we are considering this? Because if boundary has some thickness, so some heat may be transferred to this boundary also. So the system will disturb. So that is why this negligible thickness we have covered. Okay. What is universe? If you combine the system and surrounding, the thing that you will have finally is the universe. Now types of system we have. So we have three types of system: closed system, open system, and isolated system. Now I will deal it one by one. Closed system mein, what do we have in closed system? If heat transfer can take place and no mass transfer can take place, there is only two things we can transfer. First is heat and another is mass. So if heat is transferring to the system but not mass, so that system is considered as closed system. What are the example of that? The pressure cooker. Until it is not whistled, ठीक है, जब तक सीटी नहीं आ जाती तब तक जो आपका प्रेशर कुकर है, whatever the pressure cooker you have, it will behave as a closed system because it can exchange the heat by surrounding by these conducting walls. Okay, but whatever the inside is will not exchange. The mass is not exchanging. पता चल रहा है कि you have filled it with 1 kg of dal and at the final you will have 10 gram of dal. So it will be very funny, na? If you have so. So this is example of closed system. Okay. Closed system is such a system in which there will be no mass transfer. This is the restriction to it. But when we open the vessel, some of the mass means the particular dal that we have put in it and particular amount of water that we put in. So when the vessel the water has been vaporizing inside it and it will go outside. So now the water is coming outside, which means the inside mass of the system is changing. Then we cannot consider it to the closed system. Then it will become an open system. So open system में heat transfer भी can take place, mass transfer भी can take place. दोनों transfer हो सकते हैं. ठीक है. So team ka, you will see this vapors or these streams are the nothing but the tea, which is becoming vaporizing. Okay. So here heat is also transferring, plus addition mein mass is also transferred. So this system is termed as the open system. And also you can consider the example of pressure cooker, but when it is whistled up, when it is whistling, then you can say this system will become the open system, because now it is exchanging the mass also, and sorry, transferring the mass and transferring the heat also. Now if you talk about the isolated system, so what is the possibility in this open system? We have a term. In closed system, heat transfer, no mass transfer. In open system, heat transfer plus mass transfer. Now in isolated system, there will be no heat transfer, no mass transfer. So ideally, there is no such kind of system exist. But for example, we will take the thermoflask, or you can say the thermos, in which you put the hot water or cold water in the time of summer, and hot water or hot tea in the time of winter. So it will remain as cold as you put it inside and as hot as you put it inside, but not for so much of long time. But if you consider it for a very little change of time, for let's say half an hour or 1 hour, it will nearly at the same temperature, which is on which you have put it inside. Okay. So we can say the mass is not decreasing or increasing inside the thermoflask, and also the heat is not exchanging, because if the heat has been transferred, so temperature will be lowered or upward. Okay. So that is not happening with thermoflask. So we can consider it to be a isolated system, which is isolate from both energy and mass. Okay. Now basic difference in mechanics and thermodynamics. Thermodynamics. So in mechanics, we interested in the full system, not the inter molecular system of that. But in thermodynamics, we interested in the motion of these small particles. Means thermodynamics deals with the microscopic point of view of thermal physics. So this is the basic difference you would keep in mind. Okay. Because in mechanics, we take this example. Let's say, let's consider this is a block moving with a velocity 10 meters per second. We will not consider that what is the motion of that particular individual atom inside this block. So if you are interested in the atoms, which means you are dealing with thermodynamics. Okay. So it is a special case of closed system, you can say. Now, properties of system. So what should be the property of system? How can you classify a system? There is only two possibilities. It can exchange heat or exchange mass, or you can say it can transfer mass or transfer heat. Okay. So types of properties we studies. Property are the characteristics which specify the system. Okay. Suppose student of JNV Ramnagra and student of JNV Baleri. We take these two. Okay. So these two student have different kind of let's say different height, different body weight. Okay. Different situations. So these are the properties which is specifying that this student belong to JNV Ramnagara and this student belong to JNV Baleri. Okay. So these are some, there are some properties, there are some characteristics. Okay. So same thing happening with the system also. System also have some properties which characterized that okay, this type of system we are dealing with. Okay. So types of properties we have intensive property and extensive. I will tell you a trick to remember this, because whenever the student heard about the trick, na, the mind will start working there. Oh, whatever the trick is, what is the trick? Uh, Please tell us. This happens to a lot of the student, but I hope that this will not happen to you. Okay. So types of properties that we have is intensive property and extensive property. In intensive property, which is independent of mass, which means these properties are not dependent on mass, which means to classify these property, we do not take the help from mass, or we do not consider that what the mass of the system is. Okay. But in opposite to that, extensive property depends on the quantity of the system. So if you talk about the intensive property, temperature and pressure would be the intensive property, because if you consider a jar, let's say, and I have placed a partition in it. Initially, let's say this system is filled with hot water. This is the water, and this water has certain temperature, or let's say density. Density of the water here is 1000 kilogram per meter cube. Now, if I put a partition in between, here I have put a partition. So I have just half of it and half of it. Now, if you measure the density of this part, this will be 1000 kg per meter cube. And if you measure the density of this part, it should also be, and it must, 1000 kilogram per meter cube, which tells us that this density is the intensive property of the system. It is not depending on the how much amount of water we have taken. Got it? So this is it. Extensive property, mass, you can say, volume, energy. These are the extensive property. How much the mass we have. If you talk about the kinetic energy, let's say kinetic energy, what is the formula? Half mv square. If you talk about the potential energy, what is the formula? Mgh. Directly depending on mass. More the mass, more the kinetic energy, more the mass, more the potential energy. So energies are associated with the quantity of that system. Okay. Volume. If you half this, the volume will be half, because initially you are dealing with complete circle and now you are dealing with the semicircle. So the volume will be half. Okay. And mass also will be half. That is why the density is not changing. Initially density is mass by volume. Final density, when we put a separation in between, mass will be half, volume will be half. These two will cancel out, m by v again. Okay. So types of property, we have two types of property, intensive and extensive. Intensive, in से याद रखना, in, which is independent of mass. Extensive, opposite of that, which is dependent on mass or the quantity of the system. You can understand it by the example of temperature. We have taken one ice cube, temperature 0 degree Celsius. If we take number of ice cube, two ice cube, the temperature will also be there 0 degree Celsius. So temperature is the intensive property. If you take two wooden block, the mass will be double. The mass you can consider as the extensive property. Now you can do it. So I will tell you separate extensive and intensive properties. Okay. So firstly, what is density? Is it intensive or extensive? For intensive, write I in the chat box, or for intensive, write E in the chat box. So we will do it very fast, rapidly. So rapidly tell me, what is density? Very good, student of JNV Ramnagar. Any other? JNV Nizamabad, I think. Shravani Shalke is here. Bharat is here. Rajesh is here. JNV Baleri. Okay. Okay, got it. What about pressure? It is I or E? I means intensive, E mean extensive. Okay. What is temperature? It is I or E? Okay. What is viscosity? Is it I or E? I you are saying, na? E. Okay. Viscosity E. Let me write here E. Okay. Volume. Volume be E. Okay. What is specific volume? Is it extensive or intensive? Extensive. Okay. What is mass? Mass is also E. So here we will discuss about the viscosity. You have take honey. Okay. You have take a jar of honey full, or let's say, for example, you have a swimming pool of honey, okay, filled with honey. Now you put your hand and slide into it. You will feel frictional force that is offered by the viscosity of that fluid. Okay. Now you have a smaller container, okay, but it is also filled with honey. Now you put your hand and force it. What is the difference? No difference, because viscosity depends on the material, not the amount of the material. Okay. So viscosity here is intensive property. Okay. So extensive properties we have volume and mass, not the specific volume also. What is specific volume? It is 1 by rho, and rho is the density, and density does not depend on the, you know, the formula of specific volume. Specific volume is 1 upon density of the system. So density is intensive. So this will also intensive. Got it? Clear with this? Give me a thumbs up if you are clear with this. Okay. Now the microscopic and macroscopic approach. Okay. These are the two approaches that we usually apply in fluid mechanics also and in thermodynamics also. Got it? Any kind of doubt in this question? Student of JNV Ramnagra, Virendra, any kind of doubt? Any one of you? If you are clear with this, just do this. Okay. Okay, okay. So microscopic and microscopic approach, I will tell you very rapidly because these are not so much of important, but you should know about it to deal with thermodynamics. So let's say you have a block. Okay. Aluminium is the metal and you have the block of aluminium. Okay. So it is made up of lots of atom. There are lots of atom present inside it. Okay. So if you do not consider the individual atom and you are interested in the complete set of these atoms and you study the complete set of these atoms, the motion of these atoms, the temperature of this system, okay, that is the macroscopic approach. Macroscopic approach. When you discuss or analyze the system as whole, not the individual basis, but if you interested only or analyze the individual particle one at time, this atom you are specifically studying, what is the kinetic energy of this atom, what is the internal energy, what is the intermolecular forces it is facing, what is the pressure it has been applied on the wall. So this approach is termed as microscopic approach. मैक्रो मीन्स बड़ा, माइक्रो मीन्स छोटा. सो माइक्रोस्कोपिक अप्रोच. ठीक है. क्या फायदा है? व्हाट इज द बेनिफिट ऑफ इट? Benefit is this: when you apply the macroscopic approach in thermodynamics, that branch of thermodynamics is termed as the classical thermodynamics, and this is not the benefit of it, this is just the name. Benefit of it will be you will save more time because you are analyzing a lots of atom, let's say thousands of or lakhs of atom one at a time. So it will save a lot of your time, but there will be a chances of error in the system. And same thing, if you want to reduce the error, you will go according to the microscopic approach. You will pick one of the atom at a time and study it, then another atom, then study it and put the data. Then you have lots of data. And when you analyze it, we have did it in our mathematics. In statistics, we did it. We have lots of data, we analyze it, then we form a conclusion. So that branch of thermodynamics in which microscopic approach we will use is termed as statistical thermodynamics. Okay. So when you individually observe these atoms, individual atoms, so the chances of error will be reduced drastically. Okay. But the time it will take will be more. So these are pros and cons both of the process. Got it? I hope you are clear with this. Now the general meaning of state, process, and path. Let's say this is state 1. This is a home. This is state 2. Let's say this is the home of student of JNV Ramnagara. And this is the state 2, which is a student JNV Baleri. And this is a student of JNV NZB. Okay. Now you will understand what is a state, what is process, and what is path. So state is, we will have different state here. Now this is the path which is connected to the state 1 to state 2. This is the path which connects state 1 to state 3. And this is the path which connects state 3 to state 2. Okay. So paths are clear, but the process that student of JNV Ramnagara has followed to come at to meet student of JNV Baleri. The path is same, but the process will be different. Either they are taking airway, or they are taking roadway, or they are taking waterway. I think waterway is not possible there. So they are taking airway or roadway, or they are using their bicycles to reach JNV Baleri. Okay, so this is the process. But if they are following the same path and there is a connection between them is path. So when the student of JNV Ramanagra reaches to the student of JNV Baleri, then it has changed its state from JNV Ramnagra to JNV Baleri. Same thing happens with water. When we boils it, okay, so boils mean we providing heat. Now, providing of heat will be different. Either you are providing heat by rubbing your hand and just put it on the vessel. You are trying to heat it by this process. Or you have a gas stove, you on this gas, burn ethylene and uh, make the water boils up. Okay. Or you have a electric kettle, you put the water inside, then you boil it with the help of electricity. So the way to boil the water will be different. Providing heat will be different. But the boiling point, after boiling, it will convert it into vapor. This is same for everything. Now, some of the process will take more time to convert the water into gas or steam, and some of the process will take less time. Suppose you are boiling water in a with an electric kettle, so it will take less time. If you are boiling it with the help of solar solar stove, So it will take very less time. Okay. So these are the process. Got it? Now, system, state of a system. So state is defined as the condition of system described with the help of its properties. So the state that we have for a particular system is that what is the temperature of it, what is the pressure of it, okay, and what is the volume of that system. These are the properties. So this stage is nothing but the condition. If you take the example of water in the liquid state, it is termed as water. So in that, we can say that at this particular temperature, at this particular pressure, or at this particular volume, this liquid will behave as water, or this liquid is water. The state that this particular material has as liquid. But when you note the value of temperature, when it becomes steam at T is equals to 100 degrees Celsius. So when the temperature is 100 degrees Celsius, pressure is 1 atmospheric, and volume, you can say anything volume, any volume you will take. At that particular situation, this state has been changed now to the steam. So for a particular state, we have the particular or specific values of these parameters, which is pressure and temperature. And somehow we are trying to convey to us कि सिस्टम की स्टेट हम सिर्फ उसकी प्रॉपर्टी से ही बता सकते हैं कि in which state the system is. Okay, by just observing it. Got it? So this is the state. State is nothing but the condition of the system, which is described by pressure, volume, and temperature. Okay. Now, let's say this is the point where this system is at pressure P1, volume V1, temperature T1. These are the thermodynamic properties, and this is called the thermodynamic state. So with these properties, it being in this state. The system is being in this state. Okay. Now, what is the process? You can easily guess it now. Now, it is the change of state from one equilibrium state to another. Okay. One thing you will tell me, let's say, I will just clear the concept of yours. Any confusion you will have here. Let's say this is the thermodynamic system here. Okay. And we have taken the example of water. Okay. So we are heating the water. Let's say initially the water is at 10 degrees Celsius. So at 10 degrees Celsius, it's not freezing. It is in liquid state. And the pressure is 1 atmospheric. Now, when it start boiling, we measure the temperature, and the temperature is 100 degrees Celsius, and it is not changing now. Okay. Now, when the water is changing, I'm not saying that it has been changed. When the water is changing in steam, can you measure the temperature? Can you say that this is the particular state? Because for state, we need the fixed data. If you measure the temperature there, at next moment of time, the temperature will change, pressure will change. Or if you are heating this water, maybe you can constant the pressure, but you're providing heat to it, the temperature will change. So you can only said anything about the state when the system is in equilibrium. This is a very important statement that I'm making. You can only describe the state of system, any system, when it is in equilibrium, which means it is not changing the pressure, it is not changing the temperature. and not the volume also. Got it? So process we have, let's say, this is the system. At this point, the pressure is P1, volume is V1, temperature is T1. And now we have pressure P2, volume V2, temperature T2. Okay. So to achieve this state, this also be the equilibrium. To achieve this state from state 1 to state 2, what we have done is termed as the process. To achieving or to change the state from one to another, but equilibrium. Okay. I hope you are clear with the concept of process and state also now. Okay. Clear? Just give me the thumbs up if you are clear with this. So this is the state 1, this is state 2. Let's say the pressure, volume and temperature is P1, V1 and T1 here. And this point it is P2, V2 and T2. Now these two are the equilibrium state, because I have told you that you can only measure or only said anything about the state when the system is in equilibrium. Okay. Like if the temperature is changing, how can you say about the anything about the temperature? If the pressure is changing, how can you say anything about the pressure? Okay. So with the change in one equilibrium state to another equilibrium state, this change would be happened because of the process. Okay. So that we can say in another word that it is the change of state from one equilibrium state to another equilibrium state. Got it? Clear? Anyone, any kind of doubt you can ask. Now, types of process. So we have two types of process, reversible process and irreversible process. Yeah, I can explain the state of system. Here, suppose you have water. For example, we have taken water. Okay. You go in your kitchen and fill a glass of water. Okay. So this glass of water, can you made anything? Can you say anything about this water? Either it is warm or cold. You can say na. So that is the state. You are describing the state of this water. If it is at a particular temperature, particular pressure, particular volume you have taken. So these all the characteristic of this system or the properties of this system. So by saying so, we are describing the state of any system. The state is nothing but the properties at that particular instant of a system. Got it? We have a system, we have some properties of it. So these, we are describing any system with the help of these property. So it is nothing but the state of that system. Okay. This is it. Only. Do not confuse with this. Thermodynamics itself is a very confusing part of physics. Okay. And I will tell you that who has developed the thermodynamics now, they have already told us that if you have studied thermodynamics first time, we have studied it, it is not understandable. And we suppose that we have learned everything about thermodynamics. But when we studied it second time, we conflict with each other. हमें खुद में ही समझ में नहीं आ रहा कि हमने क्या पढ़ा. And these are the statement of great physicists. But when we study thermodynamics 3 times, then we get to know the process, what it is actually. So for thermodynamics, you have to put more focus of yours. Okay. Now we will finish this process. Types of process we will have: reversible process. It is when the process is reversible. Okay, you can reverse this process, which means you have at your home at JNV Ramnagara. You are going to JNV Baleri, and when you return back, this process is called the reversible process. When you achieve the same state, you are transferring yourself from state 1 to state 2, and when again you transfer yourself from state 2 to state 1, that process is termed as the reversible process. So without leaving any traces on the boundary. Okay? This is state 1, this is state 2, this is the process 1. And when you move this process from state 2 to state 1 again, then this process is termed as the reversible process. Okay? It means that the system and surrounding returned to their initial state. Got it? So you can see this. When we are extending, when we are increasing the number of weight, these green colors are the weights, because pressure means we are increasing the weight. So when we increasing the weight, the gas will be compressed. Okay. So when gas is compressed, the volume is decreasing. So you can say as the pressure increasing, the volume is decreasing. But when you remove these masses, the gas will apply the force on the piston and the piston will move up. So when the pressure is decreasing, the volume is increasing. This type of process you can say is the reversible process. Got it? Irreversible process, which cannot be reversible, which means the system cannot return to its initial conditions, okay, with the same path. So it is a process that cannot return to their original condition with the same path if reversed. Let's say this is state 1, this is state 2. This is path A we have followed, but in returning, we have followed the another path, which means another conditions we have taken. That process is termed as the irreversible process. It is just opposite to the reversible. You can see here in the piston cylinder arrangement, this is the single stroke, you can say, the engine that we put in the motorbikes. Okay, single cylinder engine we have. So you can say there, when the pressure is increasing, the upper graph is this, but when it is returning back, you can see here, when it is going down, the path it has followed is different from the path it has followed when it is returning back. So this process is termed as the irreversible process. However, the system is achieving the initial state, but with the loss of energy. Got it? So in irreversible process, we have a loss of energy and we need to put some work to get it back on the initial state. So in general, in practical life, all the process that we will see is the irreversible process because we lose energy. There is no such process in which you put the energy and then it move back without consuming the energy. Okay? So this is not happening. It is like that key, you take a weight of 100 kg, put it on the fourth floor. Okay. So when you are putting on the fourth floor, you are not doing any work. It is not like that. Okay. Now what is path? So path is the locus of all the intermediate equilibrium state of the system during a process. Let me tell you, if this is the process we have followed, so this process is made up of very number of points, and these points are nothing but the equilibrium state, because we know that In a process is nothing but change the system from one equilibrium state to the another equilibrium state. Change the state of system from one equilibrium to another equilibrium. So we have what we have did here. We have, let's say, P1, V1, T1. Then again, very close to it, we have changed it to the another equilibrium, because that in that equilibrium we are able to measure the temperature, volume and pressure. Again we change it, again. So these, we have very large number of points, and when we join these points, we will have a path. Okay, so the path is the locus of all the intermediate equilibrium state of a system during a process. Got it? So these are the basics terminologies that we need to describe thermodynamics. So in achieving the process from 1 to 2, 2 to 3, so we have moved a system from state 1 to state 2 and then state 2 to state 3. So here the path is 1, 2 and 3. This arrow describing in which direction we are moving. So we have moved from 1 to 2 and 2 to 3. So equilibrium state, because we are measuring the temperature here and pressure here. Again we are measuring pressure, temperature here. Again we are measuring pressure, temperature here. So we can measure the pressure and temperature at the equilibrium point. So these are the equilibrium point. We connect it by the dots, by the lines. So this locus that we have is termed as the path of the process. Okay. Now cycle. This is the last topic. Then we will cover it in the next class. It will hardly take 30 seconds or 1 minute. So cycle is nothing but is a collection of process in which initial and final state are same. Suppose we have state A and we have state B. So you have reached to the state A to B, and then again you have reached to the state A. So this kind of process is termed as the cycle, in which initial and final state are the same. Okay, because we have started from here and we are again reaching it here. So initial and final state are the same. So we need at least 2 cycle or at least 2 process to make a cycle. Okay, the single process cannot be a cycle. This is state 1, this is state 2. So we have completed 1 cycle, because again we have started from 1, reaching to 2, then at 3, and then again we are reaching at 1. So our final position is equals to the initial position. Okay, so this is it from my side for today. If you have anything inside your mind, any kind of doubt, query, you can tell me. Okay. Reversible process will be a cycle. Okay, you can consider the reversible process as a cycle. Okay, so this is it. Any kind of doubt you have, you can ask. Otherwise, you can leave the lecture. Thank you so much for being attentive and being responsive. Bye-bye. Have a good day. Thank you so much.